Hey guys, how you doing this morning? All right, so yesterday we talked about the parts of the atom: protons, neutrons, and electrons. And so today we're going to focus on using the periodic table in order to determine how many of each of those three things are in an atom. It's important to know that because the numbers of those particles sometimes, or a lot of times, factor into how those elements combine together. So, for example, sodium and chlorine, how they're structured and how many electrons they have is extremely important to determine how they will combine to form a new substance. So that's what we're going to focus on today. So the concept really, or the acronym that we use to understand that is called APE MAN. And so if you look at the first word here, APE, A is for atomic number, which is located here at the top of most element boxes. That's easy because once you know this number, it automatically tells you how many protons and how many electrons the element has. So in this case, carbon is an atomic number of 6. So that automatically means that there are 6 protons and 6 electrons. Okay, so those are the two easiest ones. Protons and electrons are always equal. Okay, at least in 8th grade science, protons and electrons are always equal. When you get into high school chemistry, they'll talk to you about ions and ionic bonding. But for our purposes this year, you just need to understand that the atomic number up here, the 6, tells us how many protons there are and how many electrons there are. And remember that protons are positive, electrons are negative. So what that means is if there's the same number of positive and negative charges, that means the atom overall has a neutral charge because it has equal numbers of protons and electrons, positive and negative charges. Okay? All right, so where a little bit of the challenge comes in is when we're trying to figure out how many neutrons there are, because the number of neutrons in an atom can vary. And sometimes they're going to be the same as the protons and electrons, but a lot of times they're going to be different. Okay, so we have to do a little bit of math to figure that out. So that's where the second part of the word APE MAN comes in. So M stands for mass number, which is this number right here. And we're always going to round that. Okay, we have to round it to the nearest whole number. We don't like dealing with decimals in chemistry. And that's a good thing because I don't really like dealing with decimals in the real world. So we don't want to deal with decimals. So we always have to change this number and round it to the nearest whole number. So in this case, because this digit right here is 0, that means that we're going to round this entire number to 12. So that means the mass number of carbon is 12. So we learned yesterday that protons and neutrons both have a mass of 1. Okay, so if there are 6 protons and the mass of the atom is 12, then 12 minus 6 tells us how many neutrons there are. So the atomic number is 6, right? So 12 minus 6 gives us the number of neutrons. And so in this case, the number of neutrons is 6, okay? So APE MAN is an easy way for you to kind of jog your memory and remember how to find out how many atoms or how many neutrons are in an atom. Also, how many protons and how many electrons. Okay? So again, the concept is all of the mass of the atom is in the nucleus. And both protons and neutrons equal 1 AMU. So I want you to understand it in this sense. If I have $100 and I give it to 2 people and I give student A $40, then how much money did I give student B? Okay, so I started with 100. That's my mass. 40 of it went to student A. how much of it went to student B. So we have to subtract 40 from 100 to figure out that I gave $60 to student B. Okay, so that's kind of the concept that we're working with here. Okay, so the atomic mass minus the atomic number. Okay, so mass minus atomic number gives us the number of neutrons. Okay, so let's practice a couple. So if you look here, I've got 4 different elements on the periodic table. So if we use, again, the concept of atomic number equals protons equals electrons, the atomic number for potassium is right here, number 19. Let me zoom in a little bit. Okay. So that number, automatically, we can just go into every one of these elements here and just put those numbers in the spot. Now, in order to find neutrons, we have to do a little bit of math again. So the atomic mass of potassium is 39.09. There's a 0 here, so we're just going to round the atomic mass of potassium to 39. The atomic number of potassium is 19. And so 39 minus 19 gives us 20 neutrons. So we would have 19 protons, 20 neutrons, and 19 electrons. Okay, so let's do another one. So again, APE MAN, A, its atomic number, is right here. Remember, A equals P equals E. So if this is A, then P has to be 82, and E has to be 82. All right. Now, to figure out the neutrons, we take the mass number right here. It's conveniently without a decimal, 207. And then we subtract the atomic number, which was 82. And we do that math in our head. And let's see, 18, 100, plus 5, plus 7, comes out to 125 neutrons. Okay, let's do 2 more practices. Again, A equals P equals E. Here is your atomic number, so that automatically gives us 16 protons and 16 electrons. For the neutrons, we need the atomic mass, and the R means rounded. So here's our atomic mass, 32.065. Again, that first number after there is 0. So we're going to just say the atomic mass is 32. The atomic number for sulfur is 16. And so 32 minus 16 gives us 16 neutrons. Oh, I forgot to put this up here. Okay. And then the last practice here is cobalt. Okay. So here is the atomic number. Remember, APE, A equals P equals E. So now all we have to do is find neutrons. To do that, we have to find the atomic mass. Now here, the number to the right of the decimal is a 9. So in this situation, what we would do is we would round 58.93. The atomic mass rounded of cobalt is actually 59. Okay? The atomic number of cobalt is 27. Okay, so this should come out to, do some quick math, 2, 3, that should come out to 32 neutrons. Okay, so this is what you're going to be doing, practicing for the next 2 days. Okay, again, APE MAN, just as a refresher. Okay, and you'll have a copy of this in your resources as well. APE is atomic number, tells us automatically how many protons and electrons there are. And then in order to find neutrons, we have to use the mass number minus the atomic number to give us the number of neutrons. Okay? Alrighty. So if you have any questions, again, feel free to email me. We'll talk about this in class as well. But this is Wednesday and Thursday, basically our practice with doing this, because it is really super important, understanding how to figure out how many subatomic particles are in each of the atoms on the periodic table. Okay? Alrighty. So if you don't have any other questions, make sure, like you said, if you do have questions, make sure you send them to me, email me, or make sure you ask them during our live sessions. Okay? All right. Other than that, guys, have a great day. Work hard. See you later.